that out on the USB. So if you had some, I mean, you can almost make like a plug solution.
Yeah, you can use the water in it. That's all.
We had like early on, we were thinking about putting some kind of
put water on it.
I mean, this isn't enough work on its own, but
I'm just drinking water.
with the USB, said that.
See, look, 117. Too hard.
Yeah, that's our calculation. I mean, our gas.
This is about half.
Okay, so ready?
The other thing is you can actually
So okay, this is our solution for the solar card thing. The whole idea is to capture certain driver and cabin vitals for wireless transmission using app. I'm going to run through the sensors that capture the temperature, the humidity, and the dew point sensor, as well as measuring movement. So first of all, if you look into here, on the top left, there's that sensor that captures the temperature and the humidity raw values in the room. And what I did was to then refine those raw values into actual temperature as well as humidity values, broken up into 2 different bytes for each of those values, as well as calculate the dew points independently based on the temperature and the humidity, and also broke that up into 2 bytes as well. So then it'll all go into a packet that Vipin will talk about. As well, I also used, there's a sensor on the top right corner there that I designed so as to, well, I didn't design the sensor, but I captured information that tells as, so I'll get you to zoom into there, right? So if I were to tilt this, it goes forward. If I were to leave it stalled, it goes stalled. If I were to go backward, it changes to backward. And that's to show the acceleration in the solar card, okay? So what I also did was made that into 1 byte information, captured all the 9 bytes, including a start and an end byte, and I transmitted that using a wired connection, which is this gray wire, from the propeller to the ANT controller. And I'll get Vipin to talk about the rest.
So as NCCOC mentioned, he's sending me all the sensor information, and what I've been focusing on is the wireless aspect. So the blue board, which is the propeller, has all the embedded sensors in it, and serially it sends all those bytes using UART to our ANT controller, which is the front face of our device. And essentially what this device is doing is decoding the temperature, humidity, and dew values, and wirelessly transmitting it using the ANT AP2 chip to our ANT wireless chip on the PC device, and we create a PC application powered by Engineering Technologies, of course. And it receives all the sensor bytes from the ANT controller and displays it on the right side of a PC application, which is the temperature, humidity, and dew point. Now, our team member Tamiwa is also wearing a
Heart rate monitor.
And what this wireless heart rate monitor does is it sends a heart rate wirelessly to this Garmin watch, but also to the PC application here. So if you look at the heart rate value here, it's 101 or 95, which matches with the value on the PC application. Now the PC application then sends those values to our ANT controller here, which I will control through our patented popsicle or toothpick technology to press buttons. So now when I press it, you'll see that the latest heart rate is also on our hand controller itself. So this goes into the solar car cabin, while the PC application goes into the vehicle following the solar car. So they both have real-time information. And this is our 4th year project. Thank you very much.